Assalamualaikum and hello everyone. My name is Muhammad Arif bin Anuar and my metric number is TB24028 and we are from Group 2 Section 01. So this is my group members, which is Muhammad Ikhmal bin Sharif TB24032, Muhammad Aimanduddin bin Muhammad Azman TB24020, and myself and Muhammad Fahmy bin Azmi TB24006. So today we will present our mini project, which is digital keypad Doorlock system using Mega 64 microcontroller. So let's go to our contents. This is our content as you can see here. So without wasting time, let's go to the first content, which is the introduction. So why smart door lock? Because in traditional mechanical keys have many weaknesses. You know, they can be lost, stolen, or easily duplicated. So to solve this, we designed a pin-based electronic door lock system using an Atmega 64 microcontroller. So the component that we use is Atmega 64 microcontroller itself. And then second, we got 4x3 metric keypad. Number 3, 16x2 LCD. Number 4, small motor, or it will be used as a door lock. And fifth, RGB LED plus buzzer. And the last one is emergency push button. So here is our problem statement. So first, we have identified 4 main problems with conventional mechanical locks. First, physical keys can be lost, stolen, or duplicated. And the second is there are no multi-sensory alerts. You won't know if someone is trying to break in. So number 3 is no real-time feedback. So the user don't know if the door is locked or unlocked. And fourth is manufacturing physical keys creates material waste and high metal consumption. So for the solution, our digital keypad door lock solve all this problem by replacing physical keys with a secure pin code. So here is our objective. So first is to design and simulate digital keypad lock using Atmega 64 in Proteus. Number 2, to implement metric keypad scanning for pin entry. And number 3 is interface LCD, small motor, RGB LED, and buzzer. And the last one is to provide plus acoustic feedback for first access granted or denied, lockout mode, and master pin mode. So this is our system capabilities and limitation. So as you can see here, for our several system has several capabilities. It supports 4 digital pin authentication. And then we got a lockout after 3 failed attempts, then a master pin for password reset, then a safe mode that hides the pins with asterisks, and the last one is emergency button override. However, there are also limitations. This system does not include biometric or RFID, and number 2, it got no network or IoT integration. Number 3, password stored in volatile memory. So when it will reset, it will be reset when there are some power loss. And the last one is it for simulation only, so no physical hardware implemented yet. So this is our block diagram. So on the input inside, we have the keypad and the emergency push button. This go into the Atmega 64 microcontroller, which acts as the brain of the system. The microcontroller performs password verification, lockout logic, and master mode handling. On the output outside, we have the LCD, servo motor, RGB, LED, and buzzer. This clear separation of input processing and output makes the system organized and reliable. So this is our hardware components. So let me briefly explain each hardware component. So first, the Omega is our main controller. Number 2, the 4x3 keypad is used for entering the pin. And number 3 is 16x2 LCD, which is display message such as enter pin or access granted. And then we got the servo motor, which is physically locks and unlocks the door. And then we got the RGB LED that can manage or change the color to show the system status. For example, like red for lock, blue for unlock, yellow for access deny, and others. So, and then the buzzer will provide the audio feedback such as a short beep for key press, 3 beeps for wrong pin, and a success tone for correct pin. And the final is for push button, which will allow someone inside to open the door without entering a password. So this is some software and code explanation. Now I will have explained the software side. The code is written in C for the Atmega 64. First, we have the keypad scanning here. We have the keypad scanning function called get_key in column. This uses a column toggle method. We drive each column low one at a time and read the rows to detect which key is pressed. We also add a software delay for debouncing. Okay. Second, we got the password verification. The password verification logic compares the entered 4-digit code with the stored password. which is initially set to 4444. And number 3, we got the lockout logic, which is using a counter called salah underscore period, as you can see here. So every wrong pin increments this counter. When it reaches 3, the system enters lockout mode and ignores all the keypad input. So in number 4, we got the pin mode. So the master pin mode, sorry. So the master pin mode is triggered by entering 000 hashtag. So this will allow the user to change the password. And the last one is the stealth mode, which can be toggled by pressing the star key. So when it active, the LCD shows the asterisk instead of the actual digits for privacy. So let's go to the Proteus simulation demo. Hello everyone. Today we want to demonstrate our smart door lock system project using the Omega 64 microcontroller. Before we start the simulation, here are the main components. So here is an Omega 64 chip, which acts like the brain of the system. And then we got the keypad here for pin input. Then here is LED for display the status. And here we got the LED and buzzer for visual and audio feedback. And then we got the servo motor here to simulate the physical door lock. And the last one is push button, which is to open the door from the inside. So let's start the simulation. So by the default, the system is in standby mode, which is the LCD will show the enter pin, and the LED will turn into red, and the servo motor is at 0 degrees, meaning the door is actually locked. So first, let me show you the correct password first. So by the default, the password for the system is 4444. So let me enter the password first. So we got here 4444, and then I press the hashtag button. So this means that the door will unlock for 3 seconds and the access will be granted, and then we reset again, as you can see here. Look at here. So it will lock again. So let me show you the stealth mode. So if I press the start button here, so you see the stealth mode is off. That means that when we enter the password, for example 1 2, you can see here the number, so other people can see your number for the password. So let me delete again here. So if I press the start button again, so the stealth is on. That means that when we enter the password, like look at here, so it will not show the number, so it will be more privacy to the owner. So the function for the hashtag button is to indicate whether the password is right or wrong. Okay, right now, so let's go to another function. When I put the wrong password, for example like this, so I enter the hashtag, so the LED will turn into yellow and the buzzer will beep for 3 seconds, and then it will reset again. And if I put the wrong password 3 times in a row, for example like this, and then push the hashtag button. Alright. Okay, one more time. Here, see, the system will lock and the LED will turn into red, and this red will keep blinking until we put the right password again. So let me put the right password again, 4444, and then see, it will stop beeping, buzzer will stop beeping, and then it will reset again. So for the master mode, so if the owner of the house want to change the pin, so the user just need to press, let me turn off the step mode. Right now, so when the owner want to change the pin, so first thing first, the owner must press 000 for 4 times. As you can see, 0 0 0 0, then press the hashtag button, and then we go to the master mode, and the LED will turn into the cyan color. So put the new pin. So for the last time we got the 444, right? So let me change the pin again, 1 2 3 4, and then we press the hashtag button. So you can see pin has already changed, and it turned into the green light. So if I enter the old password 4444, access will be denied because we have changed the pin. So if I put the new password, and then it will open the door. So if we want to change again the pin, just repeat the step that I have told earlier. So for the last one, for the push button, so imagine if your friend is outside the door and you inside the house. and your friend don't know the password, but your friend want to come to the house. So you just press the push button here, and then it will open the door automatically, and your friend can get into your house. So in conclusion, our smart door lock system functions perfectly and secures the door successfully. Alright, so let's go to the flowchart. So this is our flowchart here and here. So to make it easy to understand, you just can refer here. So for the path, it is starting with start, and then enter pin, and then verify. So if the verify is correct, it will unlock for 3 seconds, and after that it will relock. But if the verify is wrong, it will counter plus, and then it will automatically lock out if it is more than 3, more or equal than 3. So this is our future improvement for our projects. So for our future improvements, we suggest several enhancements. First, store the password in EEPROM so it doesn't reset after power loss. Second, add biometric authentication like fingerprint for higher security. Third, use PWM for smoother servo motor control. Fourth, integrate IoT for remote monitoring and control via smartphone. And fifth, add a backup battery for power outage. And sixth is include access logs to track entry attempts. So this upgrade will make the system more secure, reliable, and user-friendly. So we go to the conclusion. In conclusion, we successfully designed and simulated the pin-based digital door lock system using the Atmega 64 microcontroller. The system provides real feedback through LCD, RGB LED, and buzzer. It also includes important security features like lockout mode after 3 failed attempts, stealth mode for privacy, and a master pin for password reset. Our process simulation confirms that all functions work as intended. So this project demonstrated the practical application of microcontroller programming and embedded system design for real-world security solution. So this is our references, as you can see here. So that's our presentation. Assalamualaikum and thank you.